Welcome to this deep dive. I want you to just take a second and picture your own code base, like
Okay.
specifically those massive, really complex methods you or your team deal with every single day.
Yeah, the ones that handle all the core business logic, validate the rules, and, eventually coordinate saving everything to a database.
Exactly. The ones that just seem to grow like a little bit more with every sprint.
Right.
So our mission today is to take a purely objective look at a radically different way to structure those methods. We're going to look at exactly what moved during a major architectural shift, what it cost, and how it fundamentally changes how code ages.
And just to establish our contract for this deep dive right up front, this is not a hype piece. It's not a sales pitch for some flashy new web framework.
Yeah, we're not selling anything today.
Right. It's a technical dissection designed specifically for senior architects. We are auditing a real live solution by placing two entirely different architectural worlds side by side on the operating table.
The before and the after.
Exactly. On one side, the before is a traditional, widely accepted application structure. And on the other side, the after is this architecture built around something called the puppet, or the cashier approach.
Let's start by looking at that baseline, the before state, because
Huh.
honestly, any senior architect looking at this project would probably sign off on it in a code review without a second thought.
Oh, absolutely. I mean, it contains 22 files in the domain. It uses dependency injection. It relies on asynchronous interfaces.
It had proper logging in place.
Yeah, it's the standard playbook. It's how the industry has built software for years.
But the broader structure only looks sound until you zoom in on one specific method, right? The invoice async method.
Yeah, that is where the foundational issues of traditional architecture just become completely visible. This one single method is attempting to hold three distinct business domains all at once.
Which is a lot for one method.
It is. You have sales, you have warehouse, and you have accounting. And they are all living and executing together inside this single block of logic.
And the complexity doesn't even stop at the business rules, right? Because mix right into those domain verbs, you find the I/O.
Oh, the I/O is everywhere. Sprinkled throughout this one method are 6 distinct I/O call sites.
Wait, 6. Let's break those down.
Sure. So there is a log entry, a REST API call for authorization, a MySQL save,
An HTTP status code.
right, and 2 different print commands. It is all just glued together by the control flow that decides who gets the invoice and when.
I really love the analogy the sources use for this. If you were to take a highlighter and paint every single line of this invoice async method with the color of the specific domain it belongs to, you'd see the problem immediately.
The quilt analogy.
Yeah, exactly. Blue for warehouse, red for sales, green for accounting, yellow for infrastructure. It just creates this chaotic, tangled quilt.
And every piece is stitched to something else. It's impossible to pull on one thread without dragging the rest of the application with it.
The part of that quilt that really stands out to me, though, is that HTTP 400 status code. I mean, the moment the domain explicitly writes in HTTP 400, doesn't it fundamentally stop being a pure business program? Like, it just becomes hopelessly welded to the web.
It absolutely does. A business rule shouldn't know what a web browser is, right? Yet here we have core domain logic literally dictating web protocols.
But it gets worse when you look at the method signatures.
Yeah, the architectural sins are just written right there in the parameters. Take the warehouse domain in this before code. The warehouse method takes the entire cart object as a parameter.
Which seems innocent enough at first.
Until it reaches inside that cart, pulls its guts out, and iterates through the lines to check inventory.
But wait, a cart is inherently sales vocabulary. A warehouse doesn't have carts.
Exactly. A warehouse has pallets, bins, item IDs. So because the warehouse is forced to use a cart object to do its job, the warehouse domain now explicitly depends on the sales domain.
And the sales domain, I'm guessing, already depends on the warehouse to verify if an item is actually in stock before selling it.
You got it. The dependency cycle is born, sales needs warehouse, warehouse needs sales. And accounting takes the cart as well. So it tangles a third domain into the loop.
What a mess.
And to compound the issue, the cart actually saves itself. It carries a database ID and a repository interface right across those domain borders. 3 signatures, 3 borders crossed, creating a cycle that basically locks the entire system into a single monolithic assembly.
So the natural instinct for any developer looking at a tangled quilt like that is to just try and tear it apart, right? Like, let's just refactor this. We'll put sales, warehouse, and accounting into 3 clean, separate projects or DLLs.
It's the first attempt everyone makes, but when developers actually try to split this specific before code into 3 clean projects, they hit a total brick wall. The compiler throws a hard build error, MSB 4006.
Ah, MSB 4006.
Yeah,
That's the compiler basically throwing its hands up because of the cycle between sales and warehouse, right?
exactly. In typed languages, the compiler needs a linear acyclic graph to resolve types. If project A needs project B to compile, and project B needs project A.
It literally cannot build the code.
Right. The layers of abstraction didn't remove the coupling, they simply placed an interface in front of it, and the compiler sees right through that.
But let's say a team just spends a week hacking the references,
Yeah.
right? Forcing the domains apart just to get a successful build.
Okay, so they now have 3 separate DLLs. The problem is nobody can actually run them. There is no main method, there is no web endpoint, nothing saves to MySQL, and nothing prints a receipt.
Okay, I just play devil's advocate here. Looking at this tangled web, shouldn't the repository pattern save us? I mean, we're universally taught to abstract persistence. If we just hide the SQL queries inside a save method behind an interface, doesn't that fix the coupling?
Hiding the SQL inside a save interface is just, it's like hiding an inconvenient relative in a back room.
They still live in the house.
Exactly. They still live in the house. The domain is still orchestrating the save. It is still dictating exactly when persistence happens. As soon as you try to actually make these forcefully split domains run in a real application, the domain immediately absorbs all that I/O back in.
So it's not a discipline issue.
No, you cannot discipline your way out of structural entanglement. What was missing was a structural piece in the middle.
Which brings us to the core of the after picture from our sources.
Mhm.
The solution to this dependency cycle is that box in the middle. The puppet, or as it's named in the audited code, the cashier.
Right. We introduce a box in the middle that serves a very specific, very limited purpose. It is not the domain. It doesn't compute taxes. It doesn't validate business rules.
And it's not the host application either.
Right. It doesn't print receipts or save data to the database. The only thing the cashier does is save verbs. It transforms many different domain verbs into one single atomic act.
Wait, so when you say it says verbs, you mean it just acts as a pure orchestrator? It isn't checking the inventory itself?
No, it's simply looking at the various domain components and binding their actions together into a single transaction. The cashier performs an act, like invoicing. But before it commits to that act, it performs a check.
Okay, what does the check do?
It actively computes. It asks the domain what the items are really worth by checking against the price list. And notice, it checks the price list, not the physical inventory. Then it binds the bank's authorization to those exact items.
So it's essentially a gatekeeper. Like, if the bank authorized $3,000, but the items on the price list actually cost $4,000, the check catches that mismatch before any action is taken.
Exactly. The cashier just refuses to speak the verb.
And because the cashier is now sitting in the middle managing this, the individual domains no longer need to talk to each other.
Yes. The warehouse domain no longer takes a cart object. It simply takes an array of basic item IDs. The dependency cycle between sales and warehouse is completely dead.
That structural shift is huge. According to the audit, after introducing the cashier, the domain drops from 22 tangled files down to just 5 pure files.
To 5 survivors.
The 5 survivors: warehouse, ledger entries, cart, price list, and sales, which now basically just holds the verbs pulled out of the old entangled service.
And what's truly fascinating when you review the audit of these 5 files is what is completely missing from them.
The infrastructure.
Yes, zero infrastructure. If you open the .cs profile for the domain, there is no ASP.NET. There is no MySQL connector. There isn't even an item group declaring external dependencies.
It doesn't even have a reference to the Puppeteer engine that ultimately runs it, does it?
Nope. It is absolute zero I/O. The domain is completely blind to the outside world. It computes logic in a vacuum.
That level of isolation is incredible when you think about longevity. Because this code has zero I/O and zero dependencies, it could have been written in Pascal in 1988, and the core business logic would still be perfectly valid today.
And it will be valid decades from now.
Right. Code with no I/O does not age, because it is immune to the churn of infrastructure trends.
That's a profound realization. You know, moving code into a box in the middle might sound like a trivial refactor, but paradigms are built on small, fundamental moves. Think about object-oriented programming.
Okay.
Before OOP, procedural code passed state into global functions. You wrote a method like commit stock and passed in the warehouse and the cart. The entire revolution of object orientation was simply taking that first parameter and putting it on the left of the dot, like warehouse.commitStock.
Just that one tiny shift in syntax changed how the entire industry modeled the world.
And it took 25 years for that shift to fully permeate the industry. This puppet architecture isn't about putting the noun on the left of the dot. It's about putting an actor in the middle to fundamentally sever the dependencies between domains.
Okay, but if the domain is completely stripped of I/O, floating in this pure mathematical vacuum, a senior architect is immediately going to start sweating about execution.
Oh, of course.
Like, how does this application actually run? If there's no SQL connector in the domain, how does data survive a server restart?
That responsibility belongs entirely to the engine, or the puppeteer. The host application configures a performance class and chooses the storage backend. Maybe plain text for local testing or MySQL for production.
And then it starts the engine.
Right. The engine takes the acts from the cashier and serializes them. It processes them strictly one at a time, creating an island of consistency in a sea of concurrency.
So by forcing everything into a single file line, the engine entirely sidesteps race conditions.
Completely. You don't need complex distributed locks or database isolation levels because the engine is funneling every act through a single thread in memory.
Wow.
As the engine processes the acts, it journals the verb, it renders the print output, and crucially, it can replay that entire journaled history sequentially to bring the cashier back to its exact state if the system restarts.
So the domain doesn't need to know how to save itself. The engine just remembers everything the domain ever did.
Precisely.
I want to look closer at this journal, though, specifically when things go wrong. Because think about the last time you had to write a complex compensation script or a distributed rollback because a transaction failed halfway through.
The worst.
Yeah. In the traditional before system, if that check failed, say the bank authorized $3,000, but the cart cost $4,000, the system would reject it, but it would often leave behind committed stock in the warehouse.
While spitting out an HTTP 400 error to the web.
Right. Wait, so what actually happens in this puppet system when the check fails?
If the check rejects the action, it leaves behind absolutely nothing. No card is saved, no reservation is made in the warehouse, no ledger entry is created.
Wait, so if a transaction fails, we don't have to write a compensation bot or a rollback script.
No compensation bot, no manual database queries at 2 a.m. to fix stuck inventory. The sources show the exact numbers from a live run. The stock was at 98 before the purchase attempt. The bank authorized 3,000. The cost was 4,000.
The check rejects the mismatch.
Right. The journal entry was at ID4 before the attempt, and it stays at ID4 after. And the stock, it stays exactly at 98.
Oh, wow. So a rejection isn't an error state that needs to be caught and cleaned up. It simply never occurred.
A rejection is not a rollback. It is a non-occurrence. The system state remains mathematically pristine.
Okay, the act has either safely happened or safely did not happen. But once an act does happen and the engine journals it, we still have to communicate with the outside world. Where does the output go?
The act ends in one single print. But the crucial distinction here is that the engine prints values, not formats. It hands these raw values to boundary observers.
And the boundary observers decide how the data looks.
Exactly, completely isolating the domain from formatting logic. The sources show two distinct outputs generated from the exact same print. Output 1 is invoice-1.txt, a 40-line custom handmade text format for a customer's printer.
Then the other.
Output 2 is invoice-2.xml, a single-line XML document designed for a tax authority's API. Same print, same atomic act, two totally different documents handled entirely at the boundary.
That makes so much sense when you look at the cost of changing requirements.
Yeah.
The audit points out that in the traditional before architecture, adding that tax XML cost them 7 files.
Yeah, they had to modify the domain to know a tax authority existed.
But in the Puppet architecture, adding that tax XML cost exactly 1 line of code at the boundary. 0 lines changed inside the domain.
The cashier, the warehouse, the sales domain, none of them even know the tax authority exists.
Okay, we have a clean domain, a reliable engine, and boundary observers. But we need to talk about persistence. Where did the database actually go?
It was relocated, and its role was severely demoted. In the old world, the database computed and dictated the state of the business. In the Puppet world, the database simply files history.
It transitions from being the dictator of truth to just like a simple filing cabinet.
If you look at the raw rows in the MySQL server for this new architecture, it's not storing a snapshot of the business state. It doesn't store a row saying, inventory is 98.
What does it store?
It stores the arguments of a verb. It literally just stores the number 4,000 and the item IDs 1, 2, and 3. The engine uses those arguments to replay the verbs and reconstruct the state in memory.
I know some architects listening are immediately going to hear replaying verbs and think, oh, this is just event sourcing.
It's a common comparison, but you have to look closer. Event sourcing stores data on the way out. It records state changes that happen after the logic ran.
Okay.
And you have to write both the read and write halves yourself.
Right.
The Puppet architecture stores domain verbs on the way in, composed into one single act, and the engine completely owns the replay mechanism. To quote the source directly, an elephant and a crocodile both have little eyes and a tail. They are not the same animal.
I love that. They are fundamentally different beasts under the hood. So the database just stopped infecting the core logic. Whether it's plain text or a MySQL database, it's just a configuration argument you pass to the engine.
It is a massive, fundamental shift. Just to recap, we started with 22 tangled files and reduced the core domain to 5 timeless ones. We eliminated hard dependency cycles by fixing the vocabulary and putting an actor in the middle.
We made rejections leave absolutely zero trace, no more compensation scripts.
And we demoted the database to a simple filing cabinet.
It's a completely different way to think about the lifespan of your code. Which leaves me with a lingering thought for everyone listening. If stripping I/O away entirely means our core business logic literally no longer ages, how much of our industry's collective anxiety over legacy code is actually just anxiety about outdated I/O and infrastructure?
That is the real question.
Something to mull over during your next architecture review. Thanks for joining us on this deep dive.